Hi everyone, Mrs. Vara here. This video is for section 4.1, polynomial functions. So this is a lot of vocabulary that we're going to start with here first. Hoping you can see this. Yeah, I think you can. Okay, so first part is hopefully a little bit of review, just defining a monomial. Section 4.1 is all about polynomials. So monomials, we define monomials, and then a polynomial is just monomials added or subtracted together. So a monomial could be as simple as just a variable. For example, x, that's a monomial. It could be a number, which could be, a number like you're used to, 3. Could also be a fraction. That's another example of just a number. Even a square root with a number, the square root of a number is a number. So any of those could be part of a monomial. If you take a variable and you multiply it by a number, so that's what this says, the product means to multiply, the product of a number and a variable. So that would look like 3 multiplied by x, or 3x. Could be something like this, square root of 3 times x. As long as the square root is on the number and not the x, we're fine. That is a monomial. Could be a fraction with an x. So plain old number, or one of these other numbers that would, if you put them in the calculator, be a decimal. Here's some other examples. Now, a polynomial, poly means many. So a polynomial function is a monomial. So any of these you could also call a polynomial, or the sum of monomials. So it's basically when you're stringing or adding or subtracting together many monomials. A polynomial has real number coefficients. So those are, the numbers like I talked about up here. Any of those could be coefficients. When a number is multiplied by a variable, we call the number that it's multiplied by the coefficient. So coefficients are real numbers. Exponents are whole number exponents. And so we're going to say all whole number exponents. So no exponents that are not whole numbers. So the whole numbers are the counting numbers. 1, 2, 3, 4, 5. Those are whole numbers. No negative exponents. And no variables in the denominator. Now, when you're trying to decide if something is a polynomial, I think what is easiest is to list examples of what is not a polynomial. So I want you in your notes to add this little category over here, things that are not a polynomial. So it would be something that's not one of these. So, negative exponent, for example, x to the negative 1. That would not be a polynomial right here. So no negative exponents. A x, or a variable, under a square root. It's okay to have a coefficient, a number under a square root, but no variables under a square root. No exponents that aren't whole numbers. So for example, x to the 1/2, which by the way is the same as the square root of x. X to the 0.6. No exponents that aren't whole numbers. And no variables in the bottom of a fraction. So coefficients that are fractions are fine, but the fraction can't have the x in the bottom. So when we're deciding if something is a polynomial, if you see any of these happening, you're going to say, nope, not a polynomial. So standard form is when you're writing a polynomial in order so that the exponents go from big to small, or largest to smallest. So you're going to look for the biggest exponent, and the term that has the biggest exponent you're going to put in front, just like we did with quadratics, where we would say x squared plus x plus the number. The degree is the highest exponent. So once you find the term with the highest exponent, you have found the degree of that polynomial. The leading coefficient is the coefficient of the monomial with the largest exponent. Okay, when we look at an example, that will help this part. And then, so there's the degree we talk about for a polynomial, the leading coefficient. We also talk about the type. So these are your types. These should be familiar from chapter 1. Constant, linear, quadratic, cubic, quartic. So these would be the degrees for each of these types. I think it's also helpful to think about what the function would look like. So a constant would be something like y equals 2. 2 is constant, right? It's a number. It never changes. So that's why we call this a constant. If you graphed this, it would be a horizontal line. Linear, you did this a ton in Algebra 1, something like this. This is an example. You have an x to the first power. So linear, right? It's a line. Quadratic, all of chapter 3. Every function we looked at in chapter 3 had an x squared in it. So quadratic, you're going to look for the x squared. So the degree is going to be 2. These were all of your parabolas. Cubic, it's going to have an x to the third. So you could have a coefficient, that's a fraction, but then an x to the third. So degree is 3. Highest exponent is 3, so degree is 3. Cubics look like this. And quartic has a degree of 4, so you're going to have an x to the fourth. These are going to look something like this. Okay, so those are your types. All right, moving on. Yeah, we'll just keep going through the notes in this. Okay, so if you turn the page to page 2, we're now talking about end behavior. What I want you to think about for end behavior is it's just where the ends of your graph are pointing, okay? So we're going to add a little bit, I want you to add a couple coordinate grids to these notes here, just to make this a little bit easier to understand, because there's a lot in here that you have not seen before. First of all, you haven't seen with an x with this arrow. The way you read this is as x approaches. So the arrow means approaches. And this is as f of x approaches. And remember, f of x is always the same as y. So when we're talking about end behavior, for example, this graph, you first need to tell someone whether you want them to look on the right or the left. So if I said on the right side of the coordinate grid, which way is your graph pointing? You would say, oh, it's pointing up. And if I said on the left side of the coordinate grid, what's it doing? You would say, oh, it's pointing down. So this, as x approaches, is how we determine whether we want to check the right side of the coordinate grid or the left side of the coordinate grid. So the right side of the coordinate grid is where all the x's are positive, right? If I go to the right, all the x's are positive. So this right side that's written right here is referring to the right side of the coordinate grid. So if you say as x approaches positive infinity, you're telling someone, look on the right side of the coordinate grid. If you say as x approaches negative infinity, here, you're telling them, look on the left side of the coordinate grid. So this is simply giving direction for what side of the coordinate grid you'd like them to check. Now the f of x, think of the f of x as your graph. or the arrows on the ends of your graph. So this is answering the question, well, which way is your graph headed? If your graph is pointing up, we call that positive infinity. It's going up forever. If your graph is pointing down, we say, oh, it's approaching negative infinity. So that's what this means. When it says arrow, it's talking about the arrow at the ends of your graph. So if your graph is pointing up, we would say f of x approaches positive infinity. If your graph is pointing down, or your arrow, we would say f of x approaches negative infinity. So that's what we mean about end behavior. So this talks a little bit about how you determine end behavior when you're given a function. So something like f of x equals 3x to the third minus x squared plus 6. So if I'm given a polynomial function like this, I can determine the end behavior just from the equation, and that's sort of what this is talking about here. Now notice this top part of this chart has the degree is odd. So odd degrees are x to the third, x to the fifth, x to the seventh. Whenever your degree is odd, your graph is going to have one end going up and one end going down. These are x to the thirds, one end going up, one end going down. You could also have an x to the fifth that might look like this. But odd degree is always going to be one end up, one end down. Now, even degrees, those are like your x squared, your x to the fourth, your x to the sixth. Those have graphs where the ends are going in the same direction, either both up or both down. So I'm going to do this down here because this one is actually the easiest. So in this, if your degree is even, you're going to know that both ends are going in the same direction. The way you decide whether they're going up or down is you look at that leading coefficient, and if it's positive, the graph points up. This is like when we talked about quadratics and we said if a is positive, then the parabola was a smiley face. Same idea. It would also apply to an x to the fourth. If the leading coefficient, the number in front, once it's in standard form, is positive, then it's pointing up. If the leading coefficient is negative, it's pointing down. So for example, you could have something like this. Negative 2x to the fourth plus x to the third minus x. Even degree, negative leading coefficient, pointing down. An example over here would be y equals 4x squared minus 6. Even degree, positive leading coefficient, graph would point up. Now for the odds, it's a little bit trickier because you got one end up, one end down. Here's how I think is the easiest way to think about this. If the leading coefficient is positive, the right side, I'm going to erase this, get it out of my way. The right side points up. So this is an example of a leading coefficient on an odd function being positive. Right side of the graph goes up. If the leading coefficient is negative, the right side points down. All right, when we look at some examples, that will help a little. On the bottom, just some couple quick examples of circle all polynomial functions. So let's remind ourselves, what is not a polynomial? X under a square root, X on the bottom of a fraction, X with a negative exponent, or X with a fraction for an exponent. So those are all things that are not a polynomial. So when I look at this first one, I don't see any of those happening. I just see x's with whole number exponents, no negatives, no square roots. That is indeed a polynomial. When I look at this one right away, I see that square root of x. So that means this is not a polynomial. When I look at this one, I see x in the bottom of a fraction. That's another no. This is not a polynomial. This one, yeah, this is definitely a polynomial. This is a linear. Plain old x to the 1. None of this happening in there. So that is a polynomial. Okay, a couple examples, and then we will wrap up this video. So, a few things happening here. Rewrite the polynomial in standard form. So that's where we want exponents in order from biggest to smallest. Then identify the degree and the leading coefficient. If it's not a polynomial, these are all polynomials. Never mind. Okay, so here's my polynomial. First thing, write it in standard form. So I want to find my biggest exponent. There's my biggest exponent, 4. So this term has to come first. So my polynomial in standard form, still going to call it f of x. This negative 2x to the 4th is going to come first. Then I look for my next biggest exponent, x to the 3rd. First comes the 4, then comes the 3. Notice I'm just looking at exponents. I'm not looking at these numbers, these coefficients. 8 is the biggest coefficient. Don't care. Just look at the exponents. So the next term that comes will be plus 8x to the 3rd. So I've used that one, used that one. Then 3x squared. Next biggest exponent, minus 7x. This is x to the 1. Constant term hanging off the end. So now I'm in standard form. Once I'm in standard form, all I have to do is look at this first term. The degree of the whole polynomial is 4. The highest degree is going to be the degree of the whole polynomial. Remind yourself that the degree is the highest exponent. I should have written highest there. And then the coefficient that's multiplied by that variable with the highest degree is my leading coefficient. Once it's in standard form, your leading coefficient is the first number you come to. So that's negative 2. So put it in standard form, biggest exponent first, then go to your first term. There's your degree, there's your leading coefficient. Let's do another one. Okay, standard form, find your biggest exponent. There's my biggest exponent, 9. So notice when I take this term, I'm going to take that negative with it. I'm going to write negative x to the 9th. That's my first term. What's the next biggest exponent? The 6. Take the minus with it, 2x to the 6th. And then the last one is plus 8x to the 4th. Once I'm in standard form, find your first term, degree, 9. Leading coefficient, negative 1. Okay, I'm going to leave this one for you to try. Okay, we'll do one more here. So this says evaluate. That's kind of like solve. We're going to get an answer where we have f of x equaling a number. What they want us to do is to replace x with 3. So what I'm doing is wherever there's an x here, I'm going to substitute in a 3. The way that you write this is if x is 3, this isn't going to be f of x anymore. This is going to be f of 3, replacing every x with a 3. So sometimes when you come across these problems, they won't say when x equals 3, they'll just ask you to find f of 3. So that means you're replacing x with 3. So I'm going to copy this, but wherever I get an x, I'm going to put it in parentheses and replace it with a 3. So instead of 2x to the 4th, it's 2 times 3 to the 4th, minus 8, parenthesis, 3, squared, plus 5, parenthesis, 3, minus 7. If you use these parentheses, you can punch this whole line in the calculator all at once. You could also punch it in pieces and then add and subtract them, but you can punch the whole line in the calculator all at once. And if, just a refresher, this key right here, this little up hat, sometimes they call it, is how you get these bigger exponents. So if I punch this whole thing in, I'm going to have 2 parentheses 3 parentheses 2 the fourth minus 8 parentheses 3 parentheses squared plus 5 parentheses 3 parentheses minus 7, 98. And that is what that equals. So f of 3 equals 98. I'll leave this one for you to try, but I will tell you, you should get negative 90 for that one. Okay, that is all we're going to do in this video.